Hi, I'm Louis Rosenberg, CEO of Unanimous AI, and we are a very different type of AI company. While most AI researchers are out there working to replace people with algorithms, we use AI to connect groups of people together and make them smarter, significantly smarter. And so today, I'm going to be talking about accurately forecasting equities using Swarm AI. And so let me start out with just a quick outline of what I'll be going through. I'm going to start out talking about the technology, which is called Swarm AI, and it's based on the biological principle of swarm intelligence. And it uses AI to amplify the intelligence of human groups. Then I'll talk about validation of this technology, published studies that were done in conjunction with MIT, Oxford, Stanford, California State University, to demonstrate that this really works, that we can take groups of people, connect them together by AI algorithms, and make that group significantly smarter than the group would be on their own. And then I'll talk about, give some examples about how it works. I'll give an example that we did for Newsweek using this technology to forecast the Oscars. And then I'll talk about an example that we did for the United Nations, forecasting famines. And then I'll talk about a specific case study of equity forecasting that was done at Cambridge University, forecasting high volatility equities, cult stocks, and that shows the specific process. So let me start off with a controversial statement in the world of AI, namely that people are smart. Every person who's listening to me right now has a massive amount of information in their heads, knowledge, wisdom, insights, experience, intuition, instincts. And for the most part, AI is unable to access this information. It's unable to access the human database. There's a lot of work in AI where people do machine learning on data that has been captured from people, either survey data or the behaviors that they've left around as trails as they navigate the internet, that type of human data. But the real human database is inaccessible to most AI systems. And so that's really what motivated me about a decade ago to ask this question of, well, how can we best harness and amplify the intelligence of human groups? And when I started working on this problem, I really took the approach that many people take when they're tackling something new, which is, well, how does nature do it? And it turns out that nature has been addressing this problem for hundreds of millions of years. And in fact, has developed optimized methods for amplifying the intelligence of groups. And so if you can think of a group in nature, like a school of fish. School of fish has hundreds, even thousands of individuals. Each of those individuals has a slightly different view of their environment, slightly different historical experiences, slightly different personality. And yet somehow that group is able to function as a superorganism, is able to navigate the ocean, making decisions together as a group that are significantly smarter than any of the individuals could do on their own, and allows that group not just to survive, but to thrive for hundreds of millions of years as very, very successful species. So, well, how does nature do this? Well, what nature does not do to optimize the intelligence of this group, it does not take votes, does not take polls, does not take surveys. There's no survey monkey in nature. Nature also doesn't analyze big historical data sets. There's no big data machine learning in nature. What nature does is it forms systems, real-time systems with feedback loops that enable groups to converge on optimal solutions. Biologists call this swarm intelligence, and it's the reason why birds flock and fish school and bees swarm. They are significantly smarter together than alone. And so the big question that inspired us to found Unanimous AI now 7 years ago was this. Well, if birds and bees and fish can get so much smarter by working together in real-time swarms, why can't people do it? And it turns out that people can with the right technology. And so this image here is a natural swarm. And my team at Unanimous AI has been studying swarms like this for years in developing the algorithms and interfaces that allow humans to form similar swarms online. And so this is an artificial swarm. It's actually about 100 people. Each of the little magnets you see is controlled by a person logged in from anywhere around the world. And they use their mouse or their touch screen or their phone to move their mice. And they're working together as a swarm to make a financial forecast. In this case, they're forecasting the likelihood that the S&P 500 will go up in the next 72 hours. And what's happening is, as all these people are behaving, there's AI algorithms that are watching all of their behaviors in real time and controlling how that swarm moves. And so at the highest level, a swarm is a real-time system with participants acting and reacting and interacting, revealing the strength of their convictions to the underlying algorithms. Now, the key thing to understand about a swarm is that what you see as a participant, if you're part of a financial team, a group of analysts at a hedge fund making forecasts, and we have customers that are doing just that very successfully, what you see is this blue area where you're interacting just as magnets moving this glass puck around. What the AI sees is this cloud of behaviors of all these people as they're interacting in real time, expressing their sentiments, and that AI is determining how to combine their sentiments to move this glass puck so that they can reach an answer together. And so Swarm AI is the technology that's working in real time, that's analyzing these human sentiments, and it's finding the optimal combination of the group's knowledge and wisdom and insights based on the different levels of confidence and conviction that the participants are revealing by how they interact with each other in real time. And so Swarm AI at the highest level can be thought of like this. We have a networked human group of people who have knowledge and wisdom and insight and experience. We're connecting them together in real time, and we're enabling them to function as an artificial expert. And that expert can make significantly more accurate forecasts, estimations, decisions, predictions, and insights. And so, of course, you're wondering, well, does this really work? And one of the things we've done for the last few years at Unanimous AI is partner with universities, major universities around the world, to do rigorous studies and have those studies published that can validate. A study was published about a year ago in collaboration with researchers at MIT, looking at financial forecasting. And this was a 20-week study with a group of financial traders. And they were asked to make weekly forecasts of the price of gold, the price of oil, and the S&P 500 to predict as accurately as they could, would these assets increase or decrease during that calendar week. And we conducted this study with a group of forecasters. They would forecast three different ways. They would forecast alone as individuals. They would forecast by taking a majority vote, which some people refer to as the wisdom of crowds. And they would forecast by working together as a swarm, connected together, moderated by these Swarm AI algorithms. And what the published study found was that when working together as a swarm, they increased their accuracy by 26%. They were 26% more accurate in forecasting the price of oil, the price of gold, and the S&P 500, which is a significant increase. This paper's on our website, and so you can review the details if you're interested. We also published a study about a year ago with Stanford Medical School. This was a study funded by NSF, and the paper was published in the journal Nature Digital Medicine. And it was, the study was looking at groups of radiologists. And these were just small groups, 5, 6 radiologists, and they were asked to make diagnoses using Swarm AI technology. And again, the study had them make diagnoses alone, make the diagnoses by just taking a majority vote, and make diagnoses as a real-time swarm moderated by these Swarm AI algorithms. And as the published research showed, when they worked together as a swarm, we reduced their diagnostic errors by 33%. significant increase in their accuracy when they work together as a swarm. And again, these were professional radiologists who were participating. These are people who went to school for 12 years to become a radiologist, who are extreme experts at what they do. But when you take a group of experts and you connect them together as a swarm intelligence, they become a super expert that achieve accuracy levels that even the best in their field could not achieve. We published a study with Oxford University, also a little over a year ago, looking at forecasting sports. And the reason we did this is we brought together groups of people who were not experts. These were sports fans. They were just self-identified fans that we recruited over the internet. We did this in the UK, and so they forecast Premier League soccer. And the experiment was to predict 50 consecutive soccer games in the Premier League. Again, they did this as individuals, they did this as majority vote, and they did this as a swarm. And as the published study showed, when they made these sports forecasts, which team would win, as individuals, they were 55% accurate. When they took a majority vote, they were 58% accurate. So they got a little bit more accurate. A lot of people would call that wisdom of crowds. But when they worked together as a swarm, they jumped all the way up to 72% accurate. 72% accurate, and they actually outperformed the Vegas betting markets. And again, it shows that if you combine the knowledge and wisdom and insight of a group in an efficient way, you can have these really, really significant increases in accuracy. And finally, we published a study with California Polytechnic looking at business teams. This actually was a large study of 60 business teams. Each team was just 5 or 6 people, and they were asked to make subjective judgments, taking a standardized subjective judgment test that's used in lots of social science research. When they took the test as a group vote, they reduced their errors by 9%, again, wisdom of crowds. When they worked together as a swarm, moderated by Swarm AI algorithms, they reduced their errors by 52%. So massive increase in accuracy when working together as a swarm. And so that's, gives you some evidence that this really does work. How do you do it in practice? I'm going to give you a real world example. Lots of Fortune 500 companies and financial groups use Swarm to make forecasts, sales forecasts, hedge funds making equity forecasts. Most of that work, in fact, almost all of that corporate work are things I can't talk about. That's the private information of the customers, but I can talk about some other examples, one of which is some work we did for Newsweek because they published this. For a couple of years in a row, the folks at Newsweek asked us to predict the Oscars using Swarm. And to do this, we recruited just 50 regular movie fans, people over the internet. They got paid a couple dollars to participate, and their only qualification is they self-identified themselves as movie fans. And the way this process works is that we have a software platform called Swarm that is really easy to use, and all you need is just a standard browser to use it. And so these 50 participants, they were recruited over the internet. They just need to use a standard browser, Chrome, Safari, Firefox. They get a link by email or text or calendar or Slack. They click that link and they enter Swarm. Now, here's an important thing about a Swarm that makes it different than other types of information collecting from groups of people. A poll or a survey is asynchronous. You could send it out and people could reply over time. A swarm is synchronous. That's how it works. And I'll go into the science and the technology in detail in a minute. Because it's synchronous, the only limitation of using Swarm to amplify a group's intelligence is that everyone has to participate at the same time. So it's kind of like getting an invitation for a Zoom call. Everybody clicks on it at the same time. In this case, they click on it and they enter Swarm, and they enter a workspace that looks something like this. And in this workspace, there's a couple different areas. There's an area where the group can chat. And usually there's a moderator who's asking questions. So if this is a hedge fund using Swarm, there's a moderator that's going to go through and ask a series of questions about, for example, equities they might be forecasting or commodities they might be forecasting. And so that will get coordinated in the chat area. There's also an area to share media, images, video. We have lots of customers who do that, especially in the world of market research or sales forecasting. They might be showing videos or images. There's an area where you can actually see, who are the participants who have joined. And then the most important area is this central area in red where the group will swarm. And because it's the most important area, most folks just click and actually zoom in on the swarm area. And so here we were asked to forecast the Oscars. And so we had a moderator who just had a set of questions that were pre-planned. They push a button, and when they push that button, the question appears on everybody's screen at the same time. And so if I'm a participant, a question appears, which is most likely to win Best Picture. A set of answer options appear, the different movies that were up for Oscars. And then each participant can control a little magnet. And that little magnet, again, you can control it with a mouse or your touch screen or phone, and you use the magnet to pull on this glass puck to express your confidence and conviction in the answer. And you're going to have is this group engaging in this multi-directional tug of war, pushing and pulling to reach an answer, while AI algorithms are watching all of their behaviors to determine how to combine their varying levels of confidence. And so this is what it looks like when you have 50 movie fans working together with AI algorithms moderating how the swarm should move. They're all adjusting their strength and their convictions until the group can converge on an answer. And in this case, they converge on Shape of Water as the most likely movie to win Best Picture. And so we did this for all the different categories. And then we gave the predictions to Newsweek, and then Newsweek published the predictions, which put a lot of pressure on us. And then we had to wait to see how we did. And I'm sure you're wondering, well, how did we do? And did really well. So this swarm, which was just a group of 50 movie fans connected together in real time with Swarm AI algorithms, were 94% accurate in predicting the Oscars. They outperformed the experts who published their predictions in Variety magazine, LA Times, Vanity Fair. They outperformed Gold Derby, which is a crowdsourcing site where tens of thousands of people just voted on who would win the Oscars. It outperformed Bovada, which is a Vegas betting market where people cast bets as their way of predicting who would win each of the different categories. And then it outperformed the experts at Rolling Stone. And so again, connecting groups of people together in efficient ways where you can combine their knowledge and wisdom and insight using AI gives you very, very accurate forecasts. Why does it work so well? Well, an important thing to understand is that it's a feedback loop. And so again, at the surface, there's this Swarm interface, this front-end client that everybody sees on their web browser. Question appears, everybody's controlling their magnets. Again, the important thing to understand is that the AI engine is watching all of these behaviors in real time. It's seeing this cloud of behaviors, and it's determining from everybody's behavior as they adjust in real time, what is their true level of confidence in each of the different answer options. Now, the key thing is that it's a feedback loop. What that means is that question appears, everybody immediately reacts, they behave, they start pulling on the puck based on their initial reaction. As soon as they behave, the AI algorithms watch all their behaviors and determines how the swarm should start to move. As soon as the swarm starts to move, everybody changes their behavior. They react. And so what you have is the group of people influencing the AI is influencing the group of people, and they converge together on answers that significantly outperform traditional methods of harnessing the intelligence of groups. These are some of the companies that have been using Swarm. Again, for most commercial entities, I can't talk about their specific use, but there's a few I can talk about. One of the most interesting is actually the United Nations. The United Nations has been using Swarm for a little over a year to make forecasts. They don't make financial forecasts, but they actually use Swarm to predict famines around the world. And a really, really interesting application. And so there's a group inside the United Nations called the Food and Agriculture Organization, or the FAO. And they have a group of experts they call the IPC. And their task is to assess the food insecurity risk of different nations around the world. And this group of experts will have people who are experts in the climate, in the political conditions, in the current weather forecasts, in the commercial and economic conditions of different nations. And they will combine the intelligence of these different experts to assess over the next 18 months, will there be a food insecurity risk in Haiti? Will there be a food insecurity risk in Malawi? Will there be a food insecurity risk in South Africa? And these are high stakes forecasts, because based on these assessments, relief agencies will provide different levels of aid. And so the way they've been doing these forecasts is they have a group of about 20 participants. In the case of the United Nations, these people are highly distributed. They could be in 12 different countries. They all log in at the same time. And what happens is a swarm pops up on their screen, and they're asked to make assessments. And the assessment boils down to evaluating on a scale of 1 to 5 the food insecurity risk of different nations, from abundance to likely famine. And the reason I can talk about this study is that the United Nations did their own internal case study when they first started using the technology to compare Swarm to their traditional method. And their traditional method was to get this group of people together in a room together and have them sit around a table and spend hours discussing and arguing and coming to an agreement about the food insecurity risk of these different nations. And when they used Swarm to do this process, what they found is that they got very similar results, but they achieved those results significantly faster. And the group had greater buy-in to the answer. And there's the buy-in is really interesting, and there's a variety of different reasons for that. One of which is that when a group of people connect together by Swarm, you get a good sense of what everybody is doing, because you can see all this whole cloud of magnets moving around, but everybody is equal and everybody's anonymous. And so it immediately diffuses the hierarchy and politics of an organization. And so in many organizations, people don't necessarily feel free to speak their mind, or maybe some people do or some people don't. And there might be people with strong personalities who influence a group at much higher levels than they really should. People who are not as aggressive in a meeting might not influence a group as much. Whereas here in Swarm, everybody's equal, everybody's anonymous. And so you have a really true democracy to combine their insights, not based on the strength of the personality, but on their actual confidence and conviction in the elements that go into a forecast. And because the participants can actually experience in real time the group having this real time essentially negotiation and watch the swarm converge on an answer, they end up with greater buy-in to the result. Let me give another example, which is sales forecasting, and this is not specifically trading, although we do have users who use Swarm to make these type of forecasts as part of trading process. In this case, it was a large clothing retailer that wanted to make these forecasts of holiday sales. They wanted to predict the holiday sales of women's sweaters so they could optimize inventory. But again, we've seen people use Swarm for making similar type of sales forecasts to get an edge on financial trading. In this case, what they did with Swarm was that they brought together fashion conscious women that they recruited over the internet, just 3 groups of 15 for a total of 45 people. And they brought them into a swarm. And their goal was to predict which of this set of women's sweaters would sell the best in the holiday season and which would sell the worst, to see if they could get insights that could help them plan inventory. And they wanted to compare their traditional method, which would be large-scale survey, to using a swarm of just 3 groups of 15 people. And so what it actually looked like was this: a question would pop up on the screens of the participants. It said, which of the following will sell the fewest this holiday season? And then each of the participants had a set of images of the sweaters, A, B, C, D, E, F. And this is set up asking the fewest because we're doing it as a process of elimination. So they have a set of sweaters. They ask which is going to sell the fewest, and the group is deliberating. The AI algorithms are combining their insights. And in this case, they say sweater F will sell the fewest. And again, even though it looks simple to the participants, to the AI algorithms, it looks like a cloud of behaviors. And so then they went through and they did the fewest, and so they can create a ranking until they got down to the last 2, and then they said, well, which will sell the most? And this gave them a ranking from which sweater was forecast to sell the most to which sweater will forecast to sell the least. And then a few months later, after the holiday season, we could see, well, how did they do? And the actual sales of these sweaters, the 2 that were ranked the highest sold almost 1.8 million. The 2 that were ranked the lowest sold only 600,000. And so this swarm process, which was very, very fast, it gave a very good ordering or ranking of sales. And then they also compared it to their survey. And in the survey, people were asked similar questions, but as you can see, the survey did not rank the sweaters nearly as good. In fact, it ranked them backwards. The 2 that were ranked to sell the most actually sold less than the 2 that were ranked to sell the least. And in fact, overall, the top 4 chosen by this swarming process sold 23.7% more than the top 4 chosen by the traditional method, which was a survey. One more example, this goes specifically to trading, and this was done at Cambridge University Judge Business School, so we can talk about it as opposed to the work done by corporate customers. And here, this was a study that was recently done to use Swarm AI to predict high volatility equities, often known as cult stocks. And so they picked 12 volatile assets. The participants were MBA students at the University of Cambridge in their Judge Business School, who all had prior experience in financial markets. Their goal was to predict the 72-hour price movement of these 12 assets and do that every week for 9 consecutive weeks. The time required was 15 minutes a week. So this was very, very fast for them. They just need to log in, and 15 minutes a week, they'd make these forecasts. And their objective was to compare individual performance, a group vote, and Swarm AI. And the assets were the things you probably would expect them to be: GameStop, AMC, Peloton, Tesla. Bitcoin was in there, and again, 12 very common high volatile assets. And the forecasting method, well, first step was they used Swarm to rate each of the individual assets. Would it go up or down? Then they used Swarm to rank for the assets that they said would go up. They used Swarm to rank which was most likely to go up versus least likely to go up. For the ones that they had forecast would go down, they ranked which were the most likely to go down versus the least likely to go down. And then in step 4, we invested the highest ranked buy and the highest ranked sell, and we tracked performance. And it was a comparison study of the individuals, group vote, and Swarm AI. And so the first step was to rate the individual assets. And so here he said, how should we invest in AMC over the next 42 hours? And it was either a big short, medium short, no investment, big buy, strong buy. And this is what it looks like when you have a group of, I think there were 14 participants. They're all pushing and pulling. And in this case, they're predicting that over the next 72 hours. And you can see this is quite a deliberation. They should short AMC. And again, you can see that the AI sees this cloud of behaviors as it determines how the swarm should move. And what's really interesting is when you have this cloud of behaviors, as this little arrow shows, the algorithms actually can interpolate across all these behaviors and give a level of investment from no investment to short, not just as this scale of 0 to 1, but anywhere in the middle of that scale. It actually interpolates and gives you a real strength of conviction. The same thing was done. Here's Tesla, how much we invest in Tesla over the next 72 hours. And here they're going for a buy in Tesla. And again, you can see this cloud of behaviors. Did this for all the stocks. Then you'd have some that were predicted to go up, some that were predicted to go down. So then the next step was to rank the assets. And so here, for the ones that were predicted to go down, we went through this process of elimination to say which is going to go down the least in the next 72 hours. And so here you can see the group is converging on Tilray is going to go down the least. And so that one gets removed. And again, process of elimination again, which is going to go down the least. And so in this case, it went to rocket companies. And then until finally it determined which would go down the most. And we did this also for the increases. And so each week you had a best short and a best buy. And so then the question was, we would invest each week these predictions and track performance. And so the top buy was picked among these different assets, GameStop, AMC, et cetera. Top short picked among these assets, et cetera. And so how did we do? The results were as follows. The individuals who made the exact same predictions on their own, just through a survey, had an average loss over the 9-week process of 2.3%. So they lost 2.3%. The crowd, which was, and this was done by taking the most popular pick across this group of 14 individuals, lost 2%. So they had a slightly less loss. So there was some wisdom in crowds. And then the swarm, using Swarm AI, had a 15.9% gain across this period. And so here you can see the comparison. Doing this ranking process with Swarm was a significant improvement over the traditional methods of aggregating the input and had a big success. And so closing thoughts, Swarm AI, you start with networked human groups who have knowledge and wisdom and insight and experience. You connect them together in real time with AI algorithms, which allows them to function as artificial experts and generate more accurate forecasts, estimations, decisions. And the key thing to know is that what Swarm AI is going to do is you can take a group of experts, let's say a group of analysts at a hedge fund, you can be able to combine their knowledge and wisdom and insight and allow them to amplify together the accuracy of their forecasts, assessments, decisions, and predictions. It speeds the deliberation. The process is fast. Each forecast is generally done in under 60 seconds when the group actually logs in. And so for a group of, say, 12 equities, it's a 15-minute process. It reduces social barriers because everybody's equal and everybody's anonymous. They're not trying to second guess what their boss wants them to say. It promotes buy-in from the participants. And yeah, and so that is Swarm AI. That's how we amplify the intelligence of groups. It's used, like I said, by groups making equity forecasts, commodity forecasts, forecasting interest rates, et cetera. But it's also used in sales forecasting and market research. And really anytime, any place you have a group of people with knowledge and experience and you want to get the most out of their combined intelligence, this is a great process. And here is my email and company info if you have any questions. Thanks.